Okay, so in this video we're going to learn how to figure out the RNS. So let's see, we have this molecule. Okay, so here you have alcohol group and then a methyl group, a hydrogen, and chlorine group, right? So you have 4 of these groups. The stereochemistry is given in the sense that the 3D orientations are given to you, which means that the CH3 and the hydrogens are, and the hydrogen is coming towards you, OH is in the plane, and Cl is at the back. Okay, so the first thing you have to do is, of course, assign the priorities. And for assigning the priorities, you need to know the atomic number of all of these. So we know that chlorine is, of course, the highest one. So chlorine is going to get the highest number, which we just label as A. And then oxygen will get the next one, so that's B. So which means we are going in the ABC kind of priority, right? And then between hydrogen and carbon, of course, carbon is the next one. Now remember not to look at the entire group, okay? Don't look at OH, look at only oxygen, O. Whatever is the atom that's attached there, okay? So oxygen, Cl, and then for CH3, just look at carbon, don't look at the hydrogens. It's not the entire group, okay, that we're looking at. Okay, so now that we have assigned our priorities, and then of course hydrogen is D. Now remember, you will only have A, B, C, D. If you have E, you got 5 bonds on the carbon, okay, so that's wrong. So A, B, C, D is what we have. Now D is the lowest priority, okay? The smallest atomic number is the lowest priority, which means that that needs to be at the back. When you assign RNS, that is the most important thing, okay, is to make sure that your lowest priority group is at the back. That is the one biggest mistake that everybody makes, all right? So be sure to put D at the back. Now here D is in the front, okay? So which means we need to rotate this molecule, all right? So here I've shown you how to do this on a model. So here we have the model. Oxygen is the red one. Usually in these model sets, oxygen is the red one, carbon is the black one, and hydrogens is usually the white atoms. Okay, so this is our model for this kind of a molecule. That's why I always say you only need like 5 atoms. Okay, that's it. You don't really need more. You just need a tetrahedral. And once you have a tetrahedral, you can pretty much do a lot of things, okay, for stereochemistry. All right, so this is what we have. Now, what we mean by saying that hydrogen needs to be at the back or the lowest priority needs to be at the back is you need to make sure you rotate it like this, okay? So what this does, okay, it's not just an exchange of hydrogen and CH3. It's not that. It's just that if you see, the black atom on the right-hand side is moving to the left. Okay, so which means that whatever is here is moving here. It's not just you're just exchanging these two. You can't do that, okay? Or you're exchanging these two. If you were exchanging these two, you would literally have to break the bond, okay, and then exchange it, which changes everything, okay? Which changes the whole bonding that you have there. So that's not what we're doing. You're rotating the molecule, okay? So once you rotate it, now you have the Cl on this side, and now you have the CH3 here, and of course this one has not changed because you didn't need to rotate that one, okay? So you're just holding that and rotating it. So that's what you have to do in order to get the lowest priority group at the back, and that's the key thing for all stereochemistry. You have to do that in order to figure out the RNS. Now that you have this, now you have your priorities written out, so you can hold this if you want to at the back, and I'll do that. And just remember that your A priority is the alcohol, and then your B priority is the Cl, and this is the CH3. So now we're going R, okay, clockwise, right hand side, R. So that's going to be your orientation for this. So you know, keep in mind that you have to rotate the molecule and keep the lowest priority at the back.